All right, I want to talk a little bit about homogeneous systems. A homogeneous system is, of course, a system of linear equations, but each of the equations is a homogeneous equation. That is, the constant over here is equal to 0. One thing about homogeneous systems is that they are always consistent. That is, they always have a solution. Can you see the solution? Some people see it right away. X1, x2, up to xn, if we make them all equal to 0, then we have a solution. And if every one of those variables is equal to 0, then the right-hand side all adds up to, the left-hand side all adds up to 0, and of course the right-hand side already is 0. So there is always at least one solution. This is what we call the trivial solution. Trivial is kind of a funny word. It makes it sound like you didn't even have to think to get it. And, maybe some people did have to think a little bit, but that's fine. We still call it the trivial solution. Now, are there other solutions? Well, that all depends on a lot of stuff. But there are some certain things that we can say. In particular, there's theorem 1.2.1. It's called the free variable theorem for the homogeneous systems. I'm going to read it out loud and make a matrix as we're going here. It says that if a homogeneous linear system has n unknowns, so that's what I have here. That's my system that I've got drawn. And if the reduced row echelon form of its augmented matrix has R non-zero rows. So the matrix is going to look something like, so they say the reduced row echelon form? If the reduced row echelon form, so it's going to have some ones kind of down the diagonal somewhere, maybe, not all exactly on the diagonal. And who knows what all, will it be a 0 here, and I don't know there, and I don't know there, and but there's definitely zeros here. And then there's other stuff, right? Maybe some all 0 rows down on the bottom, right? Zeros all down the bottom here. The thing is, they tell me there's n variables. There's n variables means that all but this last column, these are going to be zeros here too. There's n of those, and then there's this one extra one, which are the zeros on the right-hand side here. Right? So they tell me that, and if the reduced row echelon form of its augmented matrix has R non-zero rows, so this many right here, here to here, is R. Okay? Well, if there are R non-zero rows, it means there's R leading ones. Well, if there's R leading ones, each leading one is in a column by itself. So how many columns are left? Well, there's n columns total corresponding to variables, and R of them correspond to leading variables. So there's n minus R free variables. In particular, so that's theorem 1.2.1, and then they go on to theorem 1.2.2 to essentially say, hey, if n minus R is a positive number, then you have a positive number of free variables, which means you have infinitely many solutions, right? So R is never going to be bigger than n because you're not going to have more leading ones than you have columns here. This we can make positive as long as R is less than n, if there are fewer leading ones than variables. And we can assure that that's true is if the number of equations is less than the number of variables. In a homogeneous system. Then there's infinitely many solutions. Wow. This is really time for a new fancier pen so that I can't blame my handwriting on the pen. Then there are infinitely many solutions. Because even if you have one free variable, you got a whole line worth of solutions, right? If you got two free variables, you got a plane worth of solutions, and so on. Okay. So homogeneous systems turn out to be really nice, fairly easy to see if you've got only one solution or maybe infinitely many solutions. Well, to see infinitely many, if you've got more variables than equations, you got infinitely many solutions. Um, you know you always have one solution because you got the trivial solution. Okay. So anyway, homogeneous equations, they will play, homogeneous systems, they will play a fairly substantial role in the analysis of stuff we do throughout the quarter here.